Hey guys, so what we're going to do in this lesson is we're going to just go over a few things about angles and standard position. So here I have the XY plane. This is my positive y-axis, and out over here is the positive x-axis. And this positive x-axis is where you would find the initial side of an angle. The initial side, which does not move, will always be at that positive x-axis. Then our terminal side, when our terminal side rotates in the counterclockwise direction, we create a positive angle. However, if our angle were to rotate in the clockwise rotation, we would be creating a negative angle. 0 degrees begins here. Now, it's really important that we familiarize ourselves with all of the degree measures that are really quite critical and important on a single rotation from 0 all the way around to 360 degrees. And it's also important that we become very familiar with the radian measures as well. So I'm going to go around this circle and I'm going to ask you to do the same. And I'm going to label special increments and special angle measures. The order in which I put them down on the paper is also going to be very important. So I ask that you follow the same order that I follow. The order is intentional and it'll help you in the long run. I really can't stress that enough. So here we begin at 0 degrees. If we make one full revolution, what angle do we get coterminal to 0 degrees? 360 degrees. What's halfway between 0 and 360 degrees? What angle is halfway between 180 degrees? So again, remember, 180 degrees would start here and sweep out to right there, 180. Next, what's halfway between 0 degrees and 180 degrees? Halfway. Halfway between, you would hit 90 degrees. What's halfway between 0 and 90 degrees? What is halfway between 0 and 90 degrees? Well, that's where you would find 45 degrees. Now, what we're going to do from this 45 degree mark is we're going to count by 45s all the way around the circle until we hit 360. Half of 45 is 22.5, and we don't really care for that right now. 45 is a whole number. I don't want to deal with 22.5. So we're going to count by 45 degree increments. So anything that's already labeled, you're going to think of as a bit of a checkpoint. So here we go. Going by 45s. 0. 45. 90. What angle is next? $135. Plus another 45, 180, checkpoint. Plus another 45, 225. Plus another 45, 270. Plus another 45, 315. And 45 again on top of 315 puts us at 360. So that was going around the circle labeling all of the increments of 45 degrees starting at 0 until we hit 360. That was the first layer. Now we're going to add another layer, but this layer will be a smaller increment. It will overlap some of these spots, but not all of them. We have 0. We said 1 full revolution, coterminal to 0 is 360. Halfway between 0 and 360 is 180 degrees. What is 1/2 of 180 degrees? 90. What is 1/3 of 90 degrees? 1/3 of 90 degrees is 30 degrees. 30 degrees is closer to 45 than it is to 0. It's not in the middle. We just said in the middle would be 22.5. What fraction of 180 degrees is 30 degrees? 30 degrees is 1/6 of 180 degrees. 30 degrees is 1/6 of 180 degrees. That means it will take 6 increments of 30 to hit 180. So we're going to count by 30 degrees. We're going to loop all the way around till we hit 360. Ready? 0, 30, 60, 90. That's a checkpoint. 30 more after 90. 120. 30 more after 120. 150. 30 more, checkpoint, 180. 30 more than 180. 210. Do you notice we will not overlap these middle angles, the ones that are in the middle of each quadrant? You are not going to touch. Do not touch those, okay? Can't stress that enough. 180, we said 30 more was 210. 30 more than 210, 240. 30 more than 240, checkpoint, 270. 30 more than 270, 300. 30 more than 300 is 330. 30 more than 330 is 360. So what did we do? We began at 0 degrees. We know that this is where the initial side is. This is where we start. This is important. We know that going counterclockwise from there makes positive angles, and 1 full revolution is 360. We know that halfway between 0 and 360 is 180. 18 is half of 36. 180 is a straight line. Then we said, what's halfway between 0 and 180? 90. What's halfway between 0 and 90? 45. And then we said, let's count by 45s, and that's what we did. A little annoying to do that, but we did it. Next, we started over. 0 degrees, full loop, 360. Halfway between 0 and 360, 180. Halfway between 0 and 180 is 90. What's 1/3 of 90? 30. 30 is what fraction of 180? If it's 1/3 of 90, that makes it 1/6 of 180. It's half of a third. Of, we've gone over many times, 1/2 of 1/3 of means multiply. How do we multiply fractions? You just multiply numerators and denominators, no big deal. 1/6. Then we counted by 30. It took 6 30s to make 180. 30, 60, 90, 120, 150, 180. That was 6 of them. 6 more, we get to the finish line. 210, 240, 270, 300, 330, 360. And while we counted by 30s, we never touched those angles that were exactly in the middle of each of the 4 quadrants. While we're here, do you remember the 4 quadrants? This is quadrant 1, and we go in the order of the positive angle measures. Now we're going to redo this. However, we're going to redo it using radians. Here I have another blank circle. All I do is draw a blank circle and I draw X and Y axes passing through it. Not a big deal. Trace something round in your house and boom, you're great. Okay, got something straight and something round. Here we have our x-axis, our y-axis. We said our positive x-axis is where our initial side begins. Now we learned about radians last week. 0 degrees and 0 radians occur at the same place. It's not like temperature with Fahrenheit and Celsius where they are not at the same place. They share a 0. Radians do not have units, so I'm not writing anything. I'm just putting the number 0. 1 full revolution, however, now in radians is how much? Do you remember? This is the key piece, because if you know this, you can do the whole circle. 1 full circle in radians is 2 pi. 2 pi as in 2 pi r from circumference. 2 pi is 1 full revolution in radian measure. Now, following that same logic we just used, what's halfway between 0, and remember, 0 is really 0 pi. What's halfway between 0 pi and 2 pi? 1 pi. Boom, major breakthroughs right now. This is big moments in your math careers, guys. This is major right now, this whole moment. I hope you're holding on to every word I say. What's halfway between 0 and pi? 1 whole pi, 0 pi. What is halfway between 0 pi and 1 pi? Do not overthink it. Pi over 2. Half pi is halfway between 0 and pi. Deep thoughts right there, right? I know. What's halfway between 0 pi and half pi? 0 pi and half pi. Deep thoughts again. Major thought. Pi over 4. Halfway between 0 pi and a half pi is a quarter pi. It's not a quarter of the circle, it's a quarter of pi. A little confusing. Now that's the 45-degree mark. So that tells me already, I memorized now, pi over 4 is 45 degrees. I don't have to convert it using the little method we did last week. Just know it. 2 pi is 360. Pi is 180. Pi over 2 is 90. Quarter of pi is 45 degrees. Now, fractions are your friend. Count by pi over 4s. Instead of counting by 45s, which was terribly annoying, count by pi over 4. 1 pi over 4. 2 pi over 4. But guess what? 2 pi over 4 reduces to pi over 2. So we still have our checkpoint. 1 pi over 4. In my head, 2 pi over 4. Next. Easiest adding. I don't have to do 45 plus 45 plus 45. Guess what this is? 1 pi over 4, 2 pi over 4, 3 pi over 4. Guess what this is? You guessed it, 4 pi over 4. Guess what this is? Not all at once. Yep, that's right. 5 pi over 4. You know what this guy is? It's 6 pi over 4, but we can reduce that. Those are both even numbers, and that becomes, drum roll please, 3 pi over 2. So I'm not writing it as 6 pi over 4. I'm going to reduce it because we're classy like that. We're going to reduce our fractions. Not going to leave all pieces hanging out all over the place, okay? 6 pi over 4. What's next? Always keep in mind that they were really over 4. Remember where they came from. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. I know, real hard. 7 pi over 4. 2 pi is the same as 8 pi over 4. Ding, 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 ding. We landed where we were supposed to land. All is good. I need you to care about these checkpoints because sometimes you guys count or skip a place and you don't notice because you ignore your checkpoints because you assume you're doing it correctly. But you know what happens when you assume, don't you? And if you don't, maybe Google it and find out the rest of that saying. So now, orange, 0, sure, 0 radians, full loop, full revolution, 1 full circle in radians is still 2 pi. Halfway between 0 pi and 2 pi is 1 pi. Halfway between 0 pi and pi is half pi. What is 1/3 of half pi? What is 1/3 of pi over 2? Of means multiply. 1/3 of pi over 2. Pi over 6. And like we said before, 30 degrees is 1/6 of pi. Now it means we're going to take 6 of these size angles to reach pi, but we're going to keep going till we hit 2 pi. We're going to count by pi over 6. We're going to reduce as we go, swinging open, 1 pi over 6. Next, 2 pi over 6, but they're both even. 2 pi over 6 is really pi over 3. 1 pi over 6, 2 pi over 6, 3 pi over 6, checkpoint, that is pi over 2. 4 pi over 6 is next. That reduces to 2 pi over 3. It should kind of make sense. That's 2/3 of pi. Remember where we came from. We're counting by 6. 4 pi over 6. Skip the middle. Skip it. Next. 5 pi over 6. We're almost at a whole 6 pi over 6. There it is. 6 pi over 6. That's pi. Little more than pi. 7 pi over 6. That's really 1 1/6 pi. Think about improper fractions and how they work. Sorry, my 7's so ugly. 6 pi over 6, 7 pi over 6, 8 pi over 6, but we're going to reduce that. 8 pi over 6 is 4 pi over 3. 8 pi over 6, 9 pi over 6. Does that reduce to 3 pi over 2? 9 pi over 6. Reduce a 3 from both? You betcha. 3 pi over 2 is 9 pi over 6. Next is 10 pi over 6, both even. That's really 5 pi over 3, 10 pi over 6. After 10 pi over 6 comes 11 pi over 6. And finish strong right here. After 11 pi over 6, we hit 12 pi over 6. Is 12 pi over 6 the same has 2 pi? Yes. Winner, winner, chicken dinner. We just labeled 1 full revolution of positive angle measures in radians and 1 full revolution in positive angle measures in degrees. I need you to be able to do this inside and out, as if it's the easiest thing. Like the way you know the words to your favorite song, like the way you know how to tie your shoes, like the way you know how to write your own name. I need you to watch this video over and over and over until you've got it. So I need you to know how to do your degree measures that I just did in the same order and how to do the corresponding radian measures like I just did. I need you to do it just like I did. You heard me? Degrees, radians. That's all you got to do for today is know this. You have 48 hours to crush this, to know this beautifully inside and out. So if I even ask you, what's 210 degrees as a radian measure, you could see it in your head and you're going to tell me 7 pi over 6. Okay, we could keep going just for future reference. 11 pi over 6, 12 pi over 6. This would actually be 13 pi over 6. 14 pi over 6, which would reduce 15 pi over 6, and so on. We can find larger angles. Radians are going to be a lot easier to figure out. Look how they're set up. It's much easier to find where things land. Everything that has a 6 on the bottom is going to be in these 4 places. Everything that has a 4 on the bottom will be right in the middle. Everything with a 3 in the denominator will be there, but we're going to get more into that later. I don't want you to memorize it like a picture. Absolutely not. I promise I will know that you memorize it like a picture, and you will suffer the consequences because you will not be able to do the applications of trigonometry that we need to do if you try to memorize this like a picture. So draw a new circle, draw a new X and Y axes, and do it again. Okay? Good luck. I wish you all the best.